Hey yo. Thanks for tuning into Functions 101 series again, guys. This is a Zoho CRM Community Learning Series initiative. We're really thrilled about the response we got in our previous session, and for those of you who missed out, the link is available in our community forums. Let me show you. Just go to community.zoho.com and search for Functions 101, and it'll take you right there. I got some feedback in my previous video that I was a little bit too fast, so I'm gonna slow down as much as possible this time, okay? Joining us for the second time around, we have the highly knowledgeable Sendil Kumar and Ram Prashant. They'll help us with the Q&A side of things. Alright, but before we get any further, let's refresh our memories, shall we? In our last session, we saw what Functions 101 was all about. Basically, it's a Zoho community initiative aimed at educating our users on the power of functions and how one can code in the Deluge language, a programming language for the non-programmers. We then explored the many possibilities with functions. We saw ways in which you can achieve these possibilities with our in-house coding language Deluge. Then we saw variables and expressions. Variables being keywords to store values, and expressions is basically putting together these variables, constants, and operators. Debugger statements, which allows you to display the final output. Data types like string, integer, boolean, and float. String being any alphanumeric value. Integers, the numbers without the decimals. Float is the numbers with the decimals, and Boolean is just a true or false sort of data. Now these are different types of data that we saw. And the next thing we saw are operators. We have arithmetic operators, just like how you add two values together, you subtract two values together, multiply, divide. So all of them come under the arithmetic operators. Then we spoke about relational operators like greater than or equal to, less than or equal to, not equal to, so on. So these are used, if you remember our example from last time, if the marks are greater than 40, then yes, the student has passed. So the greater than part, all of them comes under the relational operators. Then we have conditional operators. As you can see here, we have two expressions. If you want to compare both the expressions and return a Boolean output like true or false, you would use conditional operators like if expression 1 is true and if expression 2 is true, then return true. That's the first type. The second type is if expression 1 is true or if expression 2 is true, then return true. That's the second type. The last one is just an exclamation point, which pretty much negates whatever expression you give. The next thing I want to talk about is comments. Now, comments is basically giving a description to the code. Whatever you write in the comment section is not displayed in the final output, but this is used when you have a huge piece of code and you want to later on go back and see what each section of the code does. And comments help you sort of identify that. So there are two types of comments. You can write comments in a single line or give an entire description of comments. Right. The next thing we spoke about last time is the conditional statements. And I guess that's the last thing we spoke about. We have three types. There's the if, there's the if-else, and there's the if-else-if. Now, let's take the example of the marks again. If the marks are greater than 40, then yes, the student has passed. Now, if-else. If the marks are greater than 40, then display pass, else print fail. Now, if-else-if. If the student has, scored the marks more than 40, yes, he's passed the exam. Or if he scored less than 40, then he's failed the exam. I hope you understand where I'm coming at. So if you missed out all of this, do check out the video. We did cover a lot of ground, as you can see. You would have received an email from us as a follow up. We have attached the link to that too. Just check out the video and make sure you're thorough with the first half. Now, on to the next part. This is the most commonly used one in the dilute script. So please pay close attention, and I'll be really, really slow, guys, I promise. Ask a lot of questions, and I want to get this part really cleared up before we proceed any further. Okay? In this webinar, we are focusing on the two other data types, list and map. Once you get a hang of this, writing code will come easily to you, I promise. I'll start off with explaining what list and map are and then move on to some examples and exercises around it. Alright, do you remember we discussed variables and we defined name equals Anu? Let's tweak that a little bit. Let's say speaker name is Anu, right? How would you print out something like that? Name equals Anu and then info, which is our debugger statement, name. Now this helps if the point of reference is just one entity, in this case me. Now what if you have more than one entity or objects that you want to refer to? Let's say panelists as opposed to the speakers. If I want to store all the three names under the variable name, I would have to put them between curly braces and list them out one after the other like so. Voila! And there you have a list of our panel members. Very simply put, this is exactly what a list is. Now each member is actually called an element of the list. Make sure you remember the keyword element here because we'll be using that a lot. If you want more examples, let's think of all the activities you do regularly to follow up with a customer as another example for this. You will now see that there is a link in your chat box to our page. Please click on this link and share at least 3 common things that you do to follow up with your customers. The first 3 answers get brownie points. I hope you get an idea of what list is. Now on to map. What you're seeing on the left are basically icons that you see if you log into your Zoho CRM. On the bottom right hand corner, you'll see all these icons lined up one next to the other. The first one is that of recent items. Second is game scope. Third is Zia. And the fourth are the reminders. Now, the fact that I have mapped the icon to the name is what map is. I don't know how many of y'all in school had the match the following exercise, but it's something like that, where you match what it stands for. Is map making more and more sense to you? Okay, let's get into the deluge side of list and map. A list is just a collection of elements and you add them one after the other, which means whatever order you add it in is the order it remains. So it becomes easy for you to tell the system, I want something from the 3rd position from the start, or I want to see the value of something in the 5th position because it's always in that order, right? So that's the first thing we need to remember when we think about list. Now, another thing about list is it retains the order, like I said. It does allow duplicates to be stored within. A list provides a method for you to store, retrieve, and manipulate all of this data. List is pretty simple. Now let's look at map. Map allows you to store it based on a key and value basis. You have the key, which is the icons, and then you have the value, which is the name of the feature, and you kind of map them together. Make sense? You're not allowed to have duplicates in terms of keys, which means you can't have the same icon for two different features. That's fair. That'll be confusing. Okay, so the next thing and the last one about map is once you use the map and key sort of system, you can always retrieve the value from the key. You just tell the system, I want to know what is the value of this particular icon, and the system tells you, hey, the joystick stands for game scope, that sort of thing. The keys must always be in the string or in an integer format. The values can be of any type, date, boolean, you name it, right? So this is the basic difference between list and map as far as deluge is concerned. This will make more and more sense as I go through today's session, but here's a clear difference between what list and map really is. Let me give you some more simpler examples so this makes more sense, okay? How about this? In your weekly diet plan, all the items on the plan is a list, okay? But the fact that scrambled eggs with mushrooms and oatmeal is linked to a Monday's diet, now that's what map is. Make sense? Okay, I'll give you another one. In your monthly grocery list, it is the items on the list that is the list versus the items linked to your grocery section, which is the map. If you look at the list, you have like chicken, beef, sausage, ice cream. Now, all of that is a list. The fact that you can find milk, butter, and cheese in the dairy section of the grocery, now that's what map is. Okay. Another example. In this, the list of all the departments in your company would be the list, as opposed to the finances that are allotted to each department is the map. Like, for example, how 40% is mapped to the finance department for the yearly expenditure. I hope it's getting clearer and clearer. List is just a list of items, and map has like a key and a value. You map one thing to another. Here, department to the yearly expenditure, right? Let's dive deep into the list manipulations, okay? For a more accurate definition, a list is a special type of variable that can hold a collection of values in an orderly fashion. In other words, it is a linear structure where each element is known by the position that it's in. It's called an index, all right? So it starts from 0, 1, 2, and so on. So list always starts with a 0 because that's the position that you can insert the first value into. Now you can create lists in two ways. One, using a constructor, and two, by initializing another list to get an output which is a list. You know what? I'll just show you what I'm talking about. So I said there are two ways you can create a list. One is a constructor and another one is by initializing a list. Let's look at the constructor type of creating. Okay, logged into CRM. Top right, you have setup. Click on that. Look for automation. Look for actions. Look for custom functions. configure function, write your own. Okay, so here we have using a constructor. Cool. I want to say panelists are. Don't forget the curly braces because you got more than one value. Remember the double quotes because we're putting in string values. Alrighty. Now what I've done here is I've provided a variable named panelists and I've given the three panelists names here separated with a comma enclosed in curly braces. Always the semicolon. Semicolon is your best friend. Then to finally display the panelists, I have a debugger statement here, which is info and then panelists. Let's see how that looks. Ta-da! Okay, so we got the three names here. So that is how you create a list with the help of a constructor. Now, the second type that I spoke about was initializing a list with another one. So what that means is, say I'm going to talk about panelists underscore one because I don't want to get confused between the two. Now, panelist underscore one is a list and we open the list and leave it as a blank. And then we add stuff into this list. Panelists dot add, right? And then within double quotes, you add Anu. You can just click on it. So user friendly. Sendil. Add Ram. Now if I info panelists 1 without showing panelists, I would get the same Ram, Sendil and Anu. Alright, so these are the two ways you would initialize a list. Let's see both the answers together. It's pretty much the same thing. So these are the two ways of creating a list. Okay. First one is using a constructor, like so. And the second one is by initializing a list and adding the values to it, and finally displaying the list. Now I'm sure you're wondering how I figured out that I'm supposed to use the variable name dot add and then add the values when it comes to the second way of creating a list. So there are a couple of manipulations that you can do with the list. Like one, you can create a list. I just showed you the two ways you can create a list. One with a constructor. Let's go back and check. This is with a constructor, and this is by initializing yet another list in this manner, right? Now, a couple of other things you can do inside a list is you can add values, like the one we just saw here. Add values. Now I'm gonna hide this entire section by adding the comments here. So this basically looks like a long comment, okay? And we're gonna work with this section of the code, okay? So we added Anu, Sendil, and Ram. Alright, so we've created a list and we've added people into the list. And we have displayed the final output of this list using this debugger statement. What else can we do? We can remove an element from the list. Alright, let's figure that out. Now suppose I want to add another panelist, Janaki. She's with me here right now. Now, wait, she was not part of the slide, so I have to remove Janaki now. How would I do that? So panelists dot remove. Click on that, and say which number you need to remove. So when you give just remove, you're actually removing the index, removing based on the index value. In this case, since I said it starts with 0, 1, 0, 1, 2, and so on, Anu would be in 0, 1 is Sindel, 2 is Ram, and 3 is Janaki. Now I want to actually remove Janaki, so I would have to mention number 3 here, and that would give me the final output as Anu, Sendil, and Ram again. Let's see. Okay, so we added Janaki and we removed Janaki. Now, what if I didn't know Janaki was in the third position in the list and I wanted to remove her by name? Say remove. So there's this option called remove element where you can specifically mention that you want to remove Janaki off the list. Alright, let's see what else we got here. We got clear, which basically clears the whole list. Okay, let's try that out. Let's keep Janaki in the loop. Right, now clear dot, just clear, semicolon, because you don't have to mention a particular variable, just clear the whole list. If you save and execute, you don't see anything. Alright, that's good. Next is sort. Now that will sort it in ascending or descending order. If it's ascending that you're looking for, you gotta put true, and then if it's descending you're looking for, you gotta put false. Anu, Janaki, Ram, Sendil. Cool. And of course, false will give you the opposite. Okay, so if we learn some of the manipulations, now for the tricky bit. There is a for each element and for each index. Now, like you would have guessed, this is usually used when you want to loop something and say check for each object or each element in the list, right? So let's start with the first one, for each element. Going back to our examples of panelists, we have panelists, me, Sendil. I think that's the first time I got his name right without a typo. Ram and Janaki. Alright, now we want to use the for each. Now, for each element, my variable in the collection, right? Replace the my variable with any user defined variable. It can be Anu, it can be member, it can be info. Okay, it can't be info because that's a debugger statement. Basically, it can be XYZ, ABC, whatever you want. I'm just going to say for each member, which is a newly initialized variable, for each member in the panelists. Okay, so every time it checks the panelist and it goes through the loop, whatever it's checking, like for example, it'll first start with Anu. Anu will be saved in the member variable. Then after it checks Anu and gives the output, the next thing it'll check among the panelists is Sendil, and then Sendil will be stored in the members variable, so on and so forth, right? So for each member in the panelists, if the member's name by any chance happens to be Anu, and then we use our conditional operators, or if the member is Janaki, right? We say info female, otherwise your name. Okay, that should give you female, male, male, female. That is me, Sendil, Ram, and Janaki. Perfect. Now the next thing we want to see is for each index. Now index is the position. So we can't mention them by name, but then we need to mention them by position. So we would say for each index member in panelists, I still need a variable for it to look at. So if it is 1 or if it is 3, no, if it is 0 or if it is 3, then it's a female, otherwise it's a male. Okay, there we have it. Other than this, list also has some built-in functions. Let's check them out, shall we? Alright, so this is the list of the list functions. Yeah, so we have contains, which basically returns a true or false sort of response if a particular element is present in a list, right? Then we have get, which allows you to retrieve an element as at a particular position. So if you say, I want to see who's at position 0, and if you say get 0, it'll return what value is sitting in that particular position. Then we have, of course, add, which we saw already. It adds specific elements to the given list. Then we have index of. Now, index of returns the position of a given element in the list. And as we know, the first element's position is always 0, right? The last index of, that returns the position of the last occurrence of an element in the list. Now, if you remember, a list does not look for duplicates. So if you repeat Anu 4 or 5 times, it'll tell you what's the last position that Anu was in. Moving further, we have sort, which we saw earlier. If you put true between the braces, you're gonna get the sorting in the ascending order. And if you put false, you'll get the same list in the descending order. Okay. Then we have size, which returns the number of elements that you have in the list. Okay. Other than this, we also have a couple of unique functions like distinct. So if you were to repeat a certain element multiple times, if you use the function distinct, it'll give you exactly the names without the duplicates, basically the distinct values, right? Then we have intersect, which of course gives you the opposite of distinct, which gives you what are the common elements between two lists. Where does list A intersect with list B, right? We have is empty, that is to check whether a particular list is empty or not. We have sublist, which returns the sub list or a smaller list of a given list starting from the index value, and you mention how many elements you want. Okay, so out of the 4 people, if I just want Ram and Sendil's name, I would start off with index 1 because Ram is at 1, Anu is at 0. So 1, and then I would say I want 2 names that would give me Ram and Sendil. Don't worry, I will give you a demonstration of that. Then we have toList, which basically converts a string to a list if it's separated using a default separator like comma or whatever. And then of course we have the list colon string, list colon begin, which basically narrows down the list and only lets the list accept values in that particular data type. So list string means that list can only hold string values and it cannot hold any other value. Alright, so I've highlighted a couple of them, as you can see. Let's just take a look at those, and the rest are for you to play around with or figure out, or we'll also have some of them in our exercises, so you might have to play around with it to get a better understanding. But Let's get to whatever I've highlighted here for now. Again, panelists are, actually let me use a second way of initializing it. Panelists dot add, no, panelists dot add row, panelists dot add Sindel, of course, query on Janaki. Okay, info panelists should give us the list of all 4 of them. Perfect. Now let's get to each one, right? We said get. Now I said that if you want to use get, you have to mention the position that you want to get from. So you can see here there's even a syntax just to help you understand. So suppose I want to get Janaki's name. We know that Janaki is in position 3. Let me just write that here real quick. It becomes easy for y'all. Anu is in 0. Ram is in 1. Sendil is in 2. And Janaki is in 3. Right? To make this more clear. So, that being said, if you want to get Janaki's name, you would have to put... Okay, I sound like Dora the Explorer. But you have to put 3. And if you want to get only the 3 and display only that, then you use the info statement along with it. Okay, now you've pulled out only Janaki's name. Okay, that is get. Next, what else do we have? Index of. Okay, dot index of Janaki. What is that? 3, which is right. We knew that. But then, just to test if the system knows or not. The next thing we'll talk about is the size. What's the size? Size is 4. How do we check that? We say size. Ta-da. Okay. What else we got? We now have distinct. Now distinct, like I said, gives you the unique values and ignores the duplicates. So panelist dot add, let's say Sindel has been duplicated. Now if I say panelist dot distinct and I say I want to see that info, it gives me just the 4 names. It'll ignore the last Sindel because I asked for a distinct list. Now we have intersect. For intersect, we need 2 lists. So let's make another list. Panelists underscore 1 equals another list. Panelist underscore 1 dot add Anu. Panelist underscore 1 dot add Janaki. And now we want to see panelists dot intersect panelists 1. Oh, distinct. Yes. Now that gave me the only two elements that were common in both the list, which is Anu and Janaki. Let's just add another name to be 100% sure. So I'm adding another colleague's name. His name is Alshifan. But will he show up in the list? No, he will not, because he's not a common element between both the lists. Okay, so we figured out what intersect is. Now sublist. Sublist, like I said, allows you to create a smaller list by mentioning the starting and the ending index or the position from the list. To be more clear, if you were to go back to our first panelist list, and if you want to pull out just these three, right? Now this is in position 0, this is in position 1, position 2, position 3, position 4. Now if you want to pull from 2 to 4, what you do is you say info panelists, not the second one, the first one, panelists dot sublist, and you say you want to start from 2 and then till 4. ToList allows you to convert a string into a list. For example, suppose I mentioned the panelist names in this manner, like Anu or Sindil or Ram or Janaki. Now, in an ideal world, if you info or try to print that out, it'll show up with the oh yeah. So it'll show up with the forward slashes. Now, if you want to convert this into a list, right? You can just say info names dot to list and mention what's the separator that you've used. How about that? Cool. The last one I want to talk about is telling this list to strictly take values based on a certain data type. For example, now here we know that all of these are string values, right? Now suppose I want to let the list only take Boolean values. For example, is this Functions101 dot list Boolean. Now you know that you can enter them without the double quotes because it's not a string value. Okay, so it's not a dot, it's a colon. So similarly, you got to make sure you remember all the types, and these are some of the built-in list functions. Okay, so let me take a quick break. I'm sure you guys need one too. I won't be too long, and in the meantime, Ram and Sendil here will be happy to take your questions. Let's move on to maps, shall we? Remember the earlier example we saw of the icons mapped to their names? Game scope, joystick, remember? So that's what map is, and the grocery list of how Mondays map to the diet. I'm just trying to give you a better idea before we dive into map in detail. Okay? So refresh your memory on what a map is, and here we go. By definition, this allows you to store pairs of elements in the terms of keys and values. Each key is paired with a value. Okay? There are two ways of creating a map as well. You can use the key value pairs, or you can initialize it just like how we saw on the list. Let me show you both the ways. Using the key value pairs, it looks something like this. So we initialize a variable x, and within the braces we say the name maps to Anu, comma, her designation is relationship manager. She works at Zoho. We'll give you the whole list. Okay. Now, if you want to use the other one where you initialize the entire map and then state each one as a key pair value, you would do something like so. You say X is just an open map, and in the X you put name as Anu. You put the designation as manager, and you put the company as Zoho. Fair enough. And for X should give you the same output. Want to see both? Same thing, right? Alright, so now that we figured out two ways of creating a map, let's again go back to what are the manipulations in the map. So we now saw how to create a map. This is one way of creating a map. This is another way of creating a map. Let's make this more clear, shall we? This is using key value pairs, and this is by initializing a map. A couple of other things you can do is put all. Put all is basically if you have two lists and you want to put them both together. So let's say x1 is yet another list. Now x1 dot put, let's just say my age, but I won't reveal it. Now if I want to merge both of them together, I would just say x dot put all and then mention the second list or map's name and then display the first one. It should all just get merged into x, including x1. You'll see. So including age has been merged into X. So that's what put all does. Whatever you want to merge it into, you would mention it here, and what you want to merge, you'll mention here. Let's try it the other way around. Because I didn't display x1, it still shows me the value of x. But if I put x1, it's going to add age as well and give me the final output. There we go. Alrighty, so that is what put all does. Remove and clear, remove, but there is something I do need to talk about remove. Earlier we saw if you mention remove and mention the position in the list, you can remove something from the list. Or if you want to remove a particular element, you have to say remove element and then mention what the element name is. What would you do in case of map? Would you mention name or would you mention Anu, right? That'll be a common question that we get. So let me just clear this part out. Comment everything. Now we have these three, right? Now if I want to remove the name, I need to mention the keyword and not the value. So if I say remove name, it removes name and Anu and gives me just this. But if I say Anu, literally nothing happens because it does not pick up based on the value, right? So make sure you always mention the keyword here. All right. Now that's about remove. Clear is just the same clear as it is for list. Again, even in map, we have a couple of built-in functions. We have get, just like we had get in list. We have size, just like the one we saw. We can check that out here. Since there are so many, you might be wondering what the size is. So we can just check that out. X.size. Right? And see what the size is. It's 3, because I have 3 key value pairs, right? Then we have is empty. It's the same is empty as list. Contains key. Now this returns a Boolean value, which is like true or false, if a map contains a specified key, right? For example, I want to search and see if we have or we're storing the information company anyway, right? So I would want to see contains key company. Actually, if it contains key company, then print use. Let's see. Use. Okay. So it does contain the key company. Now we have yet another one which is contains value. You would have guessed what that is. I want you to check it out and experiment with that. Then we have something called keys, which returns all the keys contained in the map. So let's just say info x.keys. That'll give you the name, designation, and company, which are the keys. Values being Anu, support engineer, or relationship manager, and Zoho. Now the next thing is toMap, which we saw just like toList. It converts a string to a map. And then we have, of course, the map, which we have initialized over here. So these are a couple of built-in map functions that we have. All right, then let's summarize and see what we learned today. We learned the two data types that are list and map. We saw the various manipulations that you can do in both list and map. You know that list basically is just a collection of elements. stored in an orderly fashion, and map is more of storing the elements in a key value sort of pair, right? What all you can do has been, segregated. So the element manipulation of list is add. You can add stuff to the list using this function. Same applies for map. For accessing a certain position in the list, you can say contains, get, or remove. And all of these are based off of positions. You can search using index of or last index of. For the range, we have sublist and some unique functions like intersect, sort, size, distinct, and is empty. When it comes to map, again, the same element manipulation, which is add. Now, for key value pair operations, we have put and put all. For searching, we have contains key and contain value. For the range, we have keys. And as for the unique functions, we have size in map as well and is empty in map as well. I hope that gives you a good idea of what list and map can do in Deluge. I'll see you all again on the 22nd of August. By then, we'll start learning how to build functions from scratch. Referring to the last two videos, including this session and the previous one, will give you a good idea and will make the next session much easier. So I urge you to be really thorough on the first two sessions so that we can just go on and start building functions, okay? Thank you so much for your time and you have a good one.